they lost, or if they never expressed to begin with, and therefore later on they don't increase. That makes it almost impossible by looking at this graph, which they put all the patients together. And I don't know why they do this, but it is a very typical BioMarin thing that they usually like to report a group of patients rather than a single patient that you can look at over time and make correlations. But if you look at their paper in New England Journal of the very short-term follow-up, Figure 1, you have individual patients, and you can see that there is a very wide range of levels, which is now in page 18 here, you see that they are consistent in terms of variability. So why those patients fail? There is a question open there that we're going to learn soon because they are already pursuing this and presented in some meetings that there is something in the serum of patients that interfere with the AAV transduction, although it's not associated with the presence of neutralized antibody. So there is something in the serum that might affect transduction efficiency. So, but then to learn this, we need to know how the patient expressed to begin with and how they're expressing now. And this data from this graph on page 18, I cannot tell you. I just know some patients are subtherapeutic. That's all I can tell. But I wish I could see the same patient. Did they never express, or they express and they lost? These are two different things.
I see. And then I think a related question, so we saw maybe, Spark data. Sangamo, we only have 2 patients, so we don't have too much color on that. But, based on the Spark data, it seems if we, exclude those prophylactic patient had a response, had the cytotoxic T-cell response, the level looks more consistent compared to the BioMarin. And noted that we are talking about very small number of patients, right? Here, phase 3, we have a 16 patient, and then phase 1, 2, actually only 7 patients. So we're talking about really small number of patients. But what is your thoughts? Why there is such a wide range of this factor A level, and then related question was more the clinical the future viability of this product. I think I will save that question to later. The first is asking why the science-wise, why causing more variability here compared to, say, the Spark data.
Yeah, I think probably the answer will be related to manufacturing. Not much about the serotype because, these vectors, they are different. They're not the same serotype, but all of them, they do have a levotropes. Although we know that AAV5 and 6 are not as great as AAV8, and the Spark serotype is more like a AAV8 profile. Therefore, this should not explain the wide range. I think my impression, collectively, looking at the small number of patients over time, is the manufacturing is probably one of the key player here. Because when you do insect cell line, as I mentioned to you, you have a lot of bioproducts that they're not necessarily simple, empty, or full capsid. There are other bands that you don't know exactly what they are. And in order to clarify that, we need to see more data. And I think hopefully people will start to looking into that. But my impression is that this wide range, it means we injected quite different serotypes and different vector dose that we believe probably is not what the same way to do it. So I think in mammalian cell lines, we have a lot more transgene that we know exactly what's going on. and in not only hemophilia but other disease. It's quite predictable, and the insect cell line is much less known because only a few places use that, and therefore we need to learn.
Mm-hmm. Okay. So now we do have what is your thoughts on the prophylactic treatment with steroids? Do you think that will be a way to go? With the phase 3 data, much lower than the phase 1/2 factor A level. Do you think we also need to treat it with prophylactic steroids?
Yeah, I think when you the lesson that we learn is like for a given AAV product, once you know when the immune response will take place, maybe it's better to do prophylactically, and you do like for 8 to 12 weeks or whatever the proposal is. So I don't think because the problem with this AAV-mediated immune response is that you have a narrow window that you can introduce the steroid. A narrow window means like 48 hours. Therefore, for the clinical standpoint, it can be a nightmare. So, but if you can do prophylactic, that would be great. The problem that I think is the BioMarin as well as Unicure for factor IX use this insect cell line and baculum system, is that they don't have a T-cell mediated immune response. They have increased the liver enzyme, but they don't have the T-cell expansion. So therefore, to call that this is a immune-mediated immune response is scientifically not correct, because liver enzymes are very general biomarkers, but they're not specific. They could be for damage, they could be for immune response, they could be for any other thing. But BioMarin started to say that this was immune response, but they never show immune response to what. If it's not AAV capsid, it's something else. And I'm never agree with that argument. And actually, we wrote a review article which we mimic the increase of liver enzyme. But if you do mammalian system, the T cells specific to capsid are increased. But in the BioMarin and the Unicure, which are completely independent programs, they got the same. They have increased the liver enzyme without the T cell. To call this that is an immune mediator is a stretch. You don't know what it is.
Mm-hmm. Okay. So now, sense? That makes sense. But
what I'm saying is the fact that you are using steroids, you cannot tell that this is immune mediator. It's very specific.
Mm-hmm. I see. Okay. But your conclusion is if you use steroids, you'll be able to mitigate the potential, whether it's immune mediated or not.
Yeah,
you
both.
should be able to avoid that. Yeah, both.
Yeah.
I see. Okay.
We learned from
and then,
mm-hmm. and as well as from Spark, sometimes you don't have some patients will fail to respond.
Okay. So now, when we look at the clinical profile, do you think that, this it is approvable? I think a company basically commented, 8 out of 20 achieved the over 40% of factor A level. That will be already sufficient, pre-specified approval, the statistic requirement. So what is your view? Do you think that, current clinical profile is approvable? And then second question is that, if approved, how would you use it? Maybe first question, is this approvable?
Yeah, I think this is a very tricky question, because the way the FDA is going to look at this, or EMA, is like how many bleeds you have after gene therapy compared with the before gene therapy. Annualized bleeding rates are typically a very easy target. If you look at all these vectors that we have done, all of them, they improve the annual bleeding rates. Therefore, for FDA perspective, if you are providing prophylaxis without frequent infusion, is a criteria. But my question is always, is this the best marker or not? You need to think about this when you talk about different approach. One thing that I think is very important because of genetic disease and long life expectancy of this patient is how much vector you need. So the higher the vector dose, more riskier will be a giving approach. Therefore, you need to take not only the factor levels in the plasma and annualized bleeding rates, but also you have to ask the question, how much vector I need? If you need too much vector, might not be a great idea. So therefore, if I have to advise patient, I would say you should go with the protocol or the strategy. They use the lowest